Question 4 is another differential equation question, and they want us to give the slope field of the first indicated points. Now again, since differential equations is where your FR or AP year stops, I would highly recommend dedicating some time to differential equations. I would totally see them utilizing those somehow, especially for the separation of variables part, which is going to be part C later on. Anyways, let's find our slope fields. So I have the point 0, 0, so I need to plug in 0, 0 and see what slope I get. And that's actually going to give you a slope of 0, because you'll have 0 squared over negative 1. So maybe we want to put horizontal, since that could get a little unclear. Up next at 0, 1, remember that the 1 is the y value. Now that's 1 over negative 1 when you substitute that in. 1 over negative 1 is a slope of negative 1, so it should be like a perfect diagonal since this is scaled 1 to 1. Up next, and yeah, so I guess when you do that, imagine where the next point would be here, and imagine that you're drawing a straight line to it. That's usually what I do in those types of questions. Okay, anyways, 0, 2. Now I'm going to have 4 over negative 1, so I have negative 4. So again, it's going to be very steep, very steep. Down 4, right 1. So that'd be about there. So again, imagine you're drawing a line to that point. Okay, up next, we have the point 2, 0. This time it's still 0, still a horizontal tangent. Now, the only reason I'm writing horizontal here, and maybe you might on the exam day, is because that is, on the axis. It's not totally easy to do that. I guess, now that I think about it, as a take-home exam, they probably wouldn't have you do this anyways because you have to fill it out, or maybe there's a drag and drop feature to select it. I don't know. Anyways, let's see here. The point 2, 1. Point 2, 1 would end up being 1 over 1. So it's positive 1. Perfect diagonal. And then last but not least, 2, 2 would end up being positive 4. Alright, so there we go. That is our slope field. Up next, part B. They usually always do this. Always. There's always a differential equation and they use the tangent line and approximate. If you remember, we did this in, I think, 2017 or 2018. So again, after doing 3 years, this time around, things are looking a lot more repetitive. Again, make sure you're going through some additional past years yourself. Find some from the past and see if you can make it through them and score yourself. You should be getting comfortable understanding the formatting and reading their solutions. Anyways, so we have an initial condition. Let's write that. So again, it's y minus y1 equals m parentheses x minus x1. I guess I'm going to make a side note here and say dy dx for x equals 2, y equals 3 is, and so let's figure that out. If it's the point 2, 3, then we would have 9 over 1. So it's 9. Okay, awesome. So now, you're just kind of saying that clearly somewhere else on the page, maybe even before you jump into this, just so that they clearly understand that you calculated dy dx for those values. That's going to probably get you a point. We'll find out. Okay, so now we have our line. They want me to approximate 2.1, so prox for 2.1 would be y is approximately, and here's what I'm going to do, 9 times 2.1 minus 2 plus 3. So you can see that I'm just solving this equation. Notice I'm also using the approximate notation. Now you have to use that first. Y is approximately this stuff, but now we can say equals. Now notice, again, in this process you should always just subtract those two inside parentheses. Do not distribute the 9, because that's a really easy multiplication. You just get 0.9 plus 3. So we can say y is approximately 3.9 at x equals 2.1. And there we go. or maybe actually I have to write it like this. So I should just put 3.9 right here, and then I should say, so f of 2.1 is approximately 3.9. There we go. That's what we get. And last but not least, particular solution. So we have, we found the slope of the tangent line, but now it's time to actually solve this thing if 2, 3 is our initial condition. So part C, it's time for separation of variables. And again, there's a lot of points in this part C. There's probably 4 or 5. Trust me, I haven't looked at the scoring guideline yet, but you just start to know that when you see your differential equation question, the separation of variables is where you're getting a lot of your points. So first step, separate the variables. Don't jump to the integral. Don't be fancy. If you skip that step, you're missing out on a point. Now we're going to integrate both sides. So this one, again, be careful, this is not ln, because this is not the derivative over the original expression. This is a reverse power rule. You're actually going to end up with negative y to the negative first, and that's going to equal, this is actually ln with kind of a chain rule that actually chains to 1. So you end up with ln of the absolute value, because whenever you integrate to ln, you need absolute values. And then we're going to get plus c. Again, if you derive the inside, you just get 1 dx. If you derive everything else, you just get then once you do that and derive the ln, you just get the original contents. So you just get your dx over x minus 1. Okay, from there, let's solve this thing for y and then use the initial condition. Now probably on the scoring guideline, they use the initial condition here and then solve. I just don't like to. So it's going to take a little bit, but I'm going to write this as negative 1 over y. Ooh, interesting. Oh, thanks. All right. Negative 1 over y is ln of x minus 1 plus c. Now what I'm going to do is I'm going to get rid of the negative. So I'm just going to have 1 over y equals negative ln of x minus 1. Still plus c because the negative and the c can just absorb. Now the idea is technically all this is over 1. So what we can now do is flip everything. So we can now say y is equal to 1 over negative ln absolute value x minus 1 plus c. Okay, so now it's time to use our initial condition. So 3 is what we get when x is 2. And so that means that 3 is 1 over, well, ln of 1 is 0. That's something that you need to have memorized. Again, this is technically a non-calculator question, but you actually have your calculator at all times since it's take-home. So we have negative 0 plus c, and this is where things get a little complicated, but eventually you'll see that c is 1/3. All right. So all in all, last but not least, so f of x, that's what y is, equals 1 over negative ln x minus 1 plus 1/3. All right. Now I can already tell that their answer is going to look a little bit different. Also, cool, I have a lot of time left over, so we can look at the scoring guideline, and I don't have to speed up the video. Although I kind of like speeding it up. Saves you time, saves me time. That actually doesn't save me time, it takes me the same time. Okay, anyways, you're never going to usually see an AP exam question with a nested fraction as the final answer. I do believe that that is okay if you leave it like this, but what they're going to do is they're going to say, well, why have a denominator that has 2 parts? Why not give this ln a 3 over 3 so that this whole denominator is over 3? And then, hey, if I have 1 over something, that's the same as just flipping the something. So again, here's what I'm saying. They're going to write this as 1, the numerator, divided by your denominator, x minus 1 in the absolute value. I kind of wrote that a little sloppy at first. Plus 1 all over a common 3. So this is the whole denominator with a common 3. It was dividing 1. Now, if you know your keep, change, flip rules, then you just know that all that's going to flip So then f of x is really just 3 over, and then maybe you might even decide to write the 1 first, so you don't have to write a minus and a plus because you're a mathematician and you're lazy. So they probably wrote it like that. So let's check the scoring guideline and find out. Hopefully I got all my points. I'm starting to feel pretty good about these famous last words. Okay, so slope field, nailed it. Up next, again, yeah, you can see that they solved for dy dx, and you get 1 point for the tangent line equation, so you actually didn't need to really go through all that analysis and show it, but again, I would. And again, they got f of 2.1 is approximately 3.9. Again, notice that they say approximation. So what they mean by that is, did you actually write the squiggly equal sign? That's the mathy way of saying it. All right, up next. Again, C, part C, 5 points. First point, did you separate your variables? Next point, did you find both correct antiderivatives? Did you find the plus C and solve for C at one point? And then did you solve for Y? So, oh, that's interesting. So they actually did just keep it as a nested fraction, so I could have saved some time there. Now, then they also, this is just this note there, that's not for you, that's for all those fancy people with PhDs and people who teach the course who like to nerd out and talk about these things. You don't need to know that, as far as I know. But yeah, so there we go. Turns out you could have stopped there. And again, you should. I think I said that earlier in the video. Don't take the whole time to solve this out, because in AP, as long as your solution, if you've solved for f of x and you've isolated it, it does not matter how much you clean up this. Once it's solved for, if it is an equivalent form, you are done. So again, I would have stopped here. In fact, that's what they had. They just switched the order of the 1/3 and the ln expression. Again, that looks like a +1, but that's a -1 and an absolute value. -1 and an absolute value. Okay, and that was question 4.